fourth part of attenuated vaccine, and in this part mainly we will learn about the advantage and disadvantage of live attenuated vaccine. So first, how live attenuated vaccine works. Okay, so this we use the whole organism as live attenuated vaccine. Okay, so if it's so this kind of vaccine, they stimulates both uh, memory cellular response and also humoral immune response. Okay, and in their natural conformation, because we are using the whole organism. Okay, so however, so that's why this kind of, if we can make a live attenuated vaccine, it's always good, because they will induce both humoral and also memory cell mediated immune response, and it's most likely that as we are using the whole organism, they will induce antibody against all the antigens. Okay, all the virulent antigens of the pathogen. Okay, however, route of administration is also important for this virus. Uh, whether we are giving the vaccine orally or intravenously. Okay, so a route of administration also has role in their activity. For example, there is a very famous polio virus, the Sabin virus, polio vaccine, the Sabin vaccine. Sabin vaccine is the most famous polio virus vaccine. Okay, and it's an oral vaccine, so that's why it's very inexpensive, because if you have to give the vaccine by injection, it will become more costlier. But if you can give as we can give a Sabin vaccine orally, so it's cheap to administration. Okay, and also because of a big and also as we can give it orally, it is more effective. Why it is more effective? Because I mean this oral Sabin vaccine, it can induce immunity in the mucosal cell of the gut. Okay, and gut is the primary infection site of polioviruses. Okay, so as immunity is induced in their primary site of infection, so they provide more effective protection against poliovirus. Okay, and also Sabin virus induce IgA production in the intestine. Okay, and IgA, this kind of antibody are more prominent, more frequently present in the mucosa. Okay, a mucosa membrane of the respiratory tract or intestine. And as IgA is produced, it provide an additional protection. Okay, and this vaccine also induce IgM and IgG antibodies. Okay, so now advantage of attenuated vaccines. Attenuated live virus vaccines have the advantage of acting like natural infection with regard to their effect on immunity. Okay, they are almost like the natural. Okay, and as they are live, they can multiply inside the host. So that's why they can stimulate longer lasting antibody production. Okay, and and also induce good cell mediated response. Okay, and uh, they raise the immune response to all protective antigens, because we are using the whole organisms. Say, so that's why antibody is produced against all the protective antigens of the pathogen. Okay, and inactivation such as by formaldehyde in the case of the Salk vaccine may alter antigenicity. Okay, so actually okay, this was an example. We use the, how we attenuated them, it also has an effect of the vaccine's activity. Okay, then they offer more durable immunity and are more cross reactive. Thus, they stimulate antibodies against multiple epitopes which are similar to those elicited by the wild type virus. The cost is less to produce, because it's a live virus, so we can just produce them in large amount more easily. We just have to culture it, right? If we want to produce the virus, we just have to culture it. They give quick immunity in the majority of the vaccines. In the case of polio and adenovirus vaccines, the administration is easy because we can give them orally. These vaccines are easily transported in the field and they can lead to elimination of wild type virus from the community. Because if we give the vaccine to all the people, so eventually the wild type virus will be eliminated. Okay. Now, I mean, not only advantages, live attenuated vaccines also have some disadvantages. So, what are those? Mutation may lead to reversion to virulence. Okay, I mean, sometimes the attenuated organism they can revert and become virulent. Okay, and this is a significant advantage of live attenuated virus. Live attenuated vaccine. Okay, unrecognized adventitious agents latently infecting the culture substrates. Example, primary cell culture may enter the vaccine stocks. Okay, the problem of adventitious contaminants may be circumvented through the use of normal cells serially propagated in culture as substrate for the cultivation of vaccine virus. So what this means, I mean, if we want to make live attenuated virus vaccine, we have to culture them, right? They are live, so we need to culture them. And for virus, we need to use cell culture. So if we use primary cell culture to produce our attenuated vaccine, the attenuated virus, it can cause some problem. What type of problem? Some adventitious agent can contaminate into the vaccine. So because like the primary cell culture, okay, the primary cell line, they may contain genes of some viruses. Okay, it's actually true. The primary cell line, they I mean these kind of cells they can contain. I mean they have many integrated genes, which genes may be of some viral genes or bacterial genes. Okay, so when the primary cell culture grow, eventually this kind of hidden genes, okay, they can get expressed. Okay, and the result, result of I mean the, because as these genes can expressed, so those product those and that product can be a virus or bacteria, can contaminate the vaccine. Okay, so this will definitely create a problem, because in that case our vaccine will also contain some unwanted agent. Okay, however, we can prevent this one by changing the cell line. Okay, so I mean rather using instead of using primary cell line, if we use normal cell line. Okay, normal cell line, I mean there is a chance that normal cell line will contain less amount of those adventitious agents. Okay, so in that case if we use normal cell line, then there is a chance that we can prevent these adventitious agents from being contaminating our vaccine. Okay, another advantage is there is a potential problem that the live vaccine virus may produce persistent infection in the vaccine. Okay, and also live viruses are a problem in immunodeficiency disease patients. Okay, and then the storage and limited shelf life of attenuated vaccines present problems. Okay, I mean as they are live, we have to store them properly, so it adds some cost and sometimes it may be difficult. Okay, and also if the shelf life is low, it will be also problem, right? However, we can overcome these problems in some cases by the use of viral stabilizers. For example, magnesium chloride. Okay, if we add magnesium chloride in our vaccine stock, they can stabilize the viral. So stabilize the virus. So that's why their shelf life will be increased. Okay, and storing will be more easier because the vaccine will be more stable. Okay, and interference by co-infection with a naturally occurring wild type virus may inhibit replication of the vaccine virus and decrease its effectiveness. I mean, we are using the live attenuated virus, so it can happen that you have immunized, vaccinated a person with this attenuated virus, but that person simultaneously get infected by a wild type version of the virus. Okay, so what will happen in that case? Inside the host body, there are both the attenuated vaccine and the wild type virus. Okay, so they may compete with each other for replication, and eventually if they compete for replication, the wild type may win, and in that case, I mean, the effectiveness of the attenuated virus will be decreased. Okay, so these were the disadvantages of attenuated vaccine. Okay, so that's all for attenuated vaccine lecture. Okay, and thank you for your patience.